Swayam Prabha. Digital India. Educated India.
Have you done organometallic at all or not at all? Do you know what is organometallic chemistry? Transition metal organometallic chemistry in inorganic chemistry. This side said no, this side say yes. What have you done in that? What did you study? I'm not asking about the definition. What did you study? Metal carbonyl, catalysis, like that, or how many classes? 2 classes, 10 classes, 20 classes? Not in syllabus. It is in syllabus, but not much. Maybe 1 or 2 classes? Okay. Do you know what is metal carbonyl? I said metal carbonyl. Can you give one example? Ferrocene is not a metal carbonyl. What is a metal carbonyl then? Metal carbonyl means metal carbonyl. So there must be metal and there must be CO, right? Can you give one example? Iron. Formula is FeCO4. Any other example? Ni. Complete little properly. Don't say NiCO. Say Ni is. Okay. NiCO4, FeCO4. These are the 2 examples you have given. So you said these are the 2 examples you have given for metal carbonyl. Is the size okay? Are you able to say? NiCO4 and FeCO4. So one of them is correct and one of them is wrong, the molecular formula. No, I said one of them is correct, one of them is wrong. Somebody said FeCO4, somebody said NiCO4. One is correct, one is wrong. Can you identify which one is correct and which one is wrong? Raise your hand if you think this is correct. Raise your hand. 1, 2, 3, 4, 5. So 5 people said this is correct. If you think this is correct, raise your hand. 1, 2, 3 people raise your hand. Telling correct, and remaining people have no idea whether which is correct, which is not correct. Okay? So that means I have a job to do. If you do not know, then only I will teach, no? Okay. Have you heard of effective atomic number rule or 18 electron rule? 18 electron rule, right? Let's apply 18 electron rule. 18 electrons rule. Do you know how to calculate? If yes, start calculating for NiCO4, whether it is 18 electron or not 18 electron. How do you calculate? By taking number of electron in metal, nickel, and number of electron contributed by the ligand, which is carbon monoxide. That is the way. If you do not know, that is the way. So nickel has how many electron? We are doing 18 electron rule, right? It's called 18 electron rule. Also it is called effective atomic number rule. Okay. So shall we do 18 electron rule or effective atomic number rule? Both are essentially same thing, but the calculation is slightly different. I'll show you both. Nickel. What is atomic number of nickel? Nickel is 28. What is the next inert gas in that periodic table? If you go from nickel, zinc, like that, if you go at the end, the 0 group element, What is the atomic number of that? Okay. All right. So nickel 28. What is the electronic configuration? 1s2, 2s2, 2p6. Then what are the last thing? 1s, 2s, 2p, then 3s, 3p, 4s, and 3d. If you fill the electrons, 1s2, 2s2, 2p2, 3s2, 3p6, 3d what? 2p, sorry, 2p6, 3s2, 3p6, 3d, 8 and 4s, 2. Okay. All right. So now to make it 18 electron, how many electrons are already there in the metal that you have to say? So we count this and this. Okay, 10. The requirement is 8. Carbon monoxide donates how many electrons? 1 carbon monoxide donates 2 electrons. We need how many electrons? 8. So how many we need? 4. Therefore, there is a requirement of 8 electron because we have 8 plus 2 plus x. This should be 18. Right? So x is 8. If requirement is 8 electron and each carbon monoxide provide 2 electrons, in order to get 8 electrons, how many carbon monoxide require? A simple arithmetic. 8 divided by 2 is 4. So Ni, if you have CO4, then 4 carbon monoxide equal to 8 electron. So this 8 goes here, the total become 18. Okay, that is called 18 electron rule. Or if you say effective atomic number rule, then 28 is the atomic number, total number of electrons 28. How many more electrons are required to become 36? 8, right? So if on nickel, if we add 4 carbon monoxide, that will add 8 electrons, then it becomes 36. So this is called 18 electron rule, and that is called effective atomic number rule. Both are same thing, no difference. Okay. Iron, what is the atomic number? (26), right? How many more electrons are required? 10 electrons are required. If you go by effective atomic number rule, 36 minus 26 equal to 10. Or if you go by 18 electron rule, since this will be not 8, 6. 6 and 2, 8. So 10 more required. 10 electron means 5 carbon monoxide, hence FeCO4 is not correct. It should be FeCO5. So FeCO5. Okay. Is it difficult? No. So if you draw the formula, write the formula not correctly, wrongly, then we apply the effective atomic number rule on 18 electron rule and see whether it is correct or not. So NiCO4, FeCO5. Okay. Manganese. What is the atomic number of manganese? Iron is 26, nickel is 28, manganese is 25. Okay. So for manganese carbonyl, what will be the formula? For nickel and iron we discussed. For manganese, propose the formula. Let's say mononuclear, only one manganese, not two. Let's start with mononuclear manganese. Any trouble? I do not understand Tamil. If you tell in English, then I will understand. Not form. Okay. So how many people think it will not form mononuclear carbonyl? Raise your hand. You have to raise because you only told. How many people support him? 1, 2, 3, 4, 5, 6, 7, 8. How many people think yes, it will form, but I don't know what it is? Okay. You think it will form, but you do not know what it is. So some people say it will not form, some people say it will form, but I don't know, and remaining people did not respond. Right. So when you do not respond, then why? Are you not interested in the topic, or you are thinking maybe if I say something and it will not be correct? Don't think like that. When you give silly answer, then you learn better. Rather than not responding, try to respond. If you give wrong answer, don't worry. Try to respond. So when I say it will form or not, you say it will not form. What happens if I say MnCO5? How many electron it will be? Total number of electron will be? No, not 10. Total, together, 18 electron rule if we apply, it becomes 17. Okay. If I say MnCO6, it will be 19. And what we want? 18. Okay. If it is 17, how to make it 18? If it is 19, how to make it 18? If we add one electron, 17 become 18. If we remove one electron, 19 become 18. So let's say MnCO5 minus how many electrons? 18. Or MnCO6 plus how many electrons? 18. So mononuclear manganese carbonyl is possible, but it is not neutral. It has to be charged, either negatively charged or positively charged. MnCO5 minus or MnCO6 plus. What is the geometry of nickel tetrahedral? FeCO5 iron penta, NiCO4 tetrahedral. FeCO5? Tell complete word, don't say square, square pyramidal. And okay, and MnCO6 plus octahedral. Okay. FeCO5 is not square pyramidal. Something else? Yeah, what is the other choice? Trigonal bipyramidal. That's a trigonal bipyramidal. Tetrahedral, trigonal bipyramidal, and octahedral. Okay. So now slowly you are understanding how to count the electron. Okay. The other way is MnCO5 is 17 electron. We want to add there 1 electron to make it 18. Right? That's the idea. Okay. Remember the octet rule. Chlorine atom. How many electron it has? 7. One more chlorine atom. How many electron at the periphery? 7. But when it forms a bond, then this chlorine become 8, that chlorine also become 8, but nothing is added from outside. Right? So if it form a bond with something which can give 1 electron, then it gets 1 electron. For example, carbon, methyl radical. Octet is not filled. One more methyl radical, octet is not filled. Bring them together, both get octet. Bring one hydrogen atom to the methyl radical, both become outer shell filled, 8 and 2. Right? So methyl is considered as a species having 1 electron, which is looking for 1 electron to share. MnCO5, there are 17 electrons. It's looking for 1 electron. Methyl is also looking for 1 electron. Okay. So if MnCO5 and CH3 are together, Okay. MnCO5 has 17 electron, methyl has 1 electron. Now the manganese will get 18 electron because methyl is now connected to manganese. How it will be connected? Like octahedral, M is metal. Octahedral, there are 5 carbon monoxide, 1 is methyl. Then it become 18 electron species. So now in that compound MnCO5CH3, metal is there, carbon monoxide is there, something else is also there. What is there? Something else? Methyl, alkyl group. Okay. When only one kind of ligand is there, that is called a homoleptic. If more than one kind, it's called heteroleptic. So that's a heteroleptic metal carbonyl and 18 electron, right? MnCO5CH3. So there are different ways of making mononuclear manganese carbonyl. One, if it is homoleptic, it has to have a minus charge or a plus charge. If it is heteroleptic, then add something which is 1 electron donor. Like methyl, there are now thousands of things which can add. Ethyl, why not? Right? Just a hydrogen. So many things can be added. The purpose is to get 1 electron. Right? So this is one simple example and it will be encountered in many places. So I give MnCO5CH3. So now we have got some confidence about this formula. If we take MnCO5, it's looking for 1 electron, methyl is looking for 1 electron. Likewise, if you take 2 MnCO5, if you take 2 chlorine atom, it forms a bond and it becomes Cl2. If you take MnCO5 and 1 more MnCO5, they can also form a bond, forming MnCO5 and MnCO5, which is Mn2CO10, right? Now it become binuclear, not mononuclear anymore. It's homoleptic but binuclear, 2 metal, right? Its structure is like okay. M is manganese. Around one manganese, there are 5 carbon monoxide. Around other manganese, also there are 5 carbon monoxide. And there is a bond between manganese and manganese. So how to calculate that how many bonds are there? We know how to calculate this 18 electron rule. If there are 2 metal, then it should be 2 times 18. Okay. So let's say I know the formula of the compound is Mn2CO10, but I do not know whether there are metal-metal bonds or if metal-metal bonds, how many are there. In that case, let's say we do not know and start calculating. Manganese, how many electron we will consider here? Okay, we can. Anything which donate 1 electron is good enough. Alright, so coming back to the counting electron, manganese we say how many electron? So that is 7. So 7 for 1 manganese, there are 2 manganese. 2 times 7. 2 times 7 is 14. Carbon monoxide, each will give 2. There are 10. So 10 times 2 is 20. Total is 34. Since there are 2 metal, the total number of electrons should be 18 and 1 more 18. 2 times 18, 36. Shortage is how much? 2. So shortage is 2 electrons is shortage. Whatever is the shortage, that has to be divided by 2 to calculate number of metal-metal bonds. 2 divided by 2 equal to 1. Okay. Or if you already know there is 1 metal-metal bond, then you have to add 2 electron to this. If you are said that this compound has one metal-metal bond. Verify whether it obeys 18 electron rule or not. In that case, you have to add 1 time 2 because one metal-metal bond. Okay, 1 time 2, that becomes 34 plus 2 is 36. If you do not know how many metal-metal bond, calculate C the shortage, divide by 2. If you already know how many metal-metal bond, add 2 for every metal-metal bond to see whether the number matches or not. Okay. So, if I give you another formula and say there are metal-metal bonds, but how many you calculate, you should be able to do now. Okay. CO4, CO12, cobalt 4 times, carbon monoxide 12 times. How many you got? How many electrons? How many metal-metal bonds? 6. Who got 6? Raise your hands. Okay. So those who has not yet got, let's take a little bit more time. If you are not able to do, then I will not wait for longer. Now try to draw the structure. Try to draw the structure. Those who have not calculated, consider 6 and try to draw the structure. Six metal-metal bond you have to put and 4 metal. Are you able to do it? No? Okay. Who can do it? Can you come to the board and draw it? Draw it on the board. Don't worry. What will happen? Maximum it will be a mistake. Draw the structure here. Okay, now you can go. So what you have to do is, here is a line crossing. One is in front, one is behind. Whatever is behind, then you make a little cut like that. Okay, so it's a tetrahedron. 3 carbon, 3 cobalt are in one plane, and the other one is above. Okay, CO4, CO12, and the carbon monoxide. There are sometimes carbon monoxide at terminal, sometimes they are bridging. Terminal or bridging you may not be able to predict, but at least you should be able to predict number of metal bond and how the structure may be. Do you know this book? This is a book called Basic Organometallic Chemistry, for which the authors are called B.D. Gupta and A.J. Elias. They were faculty from IIT Kanpur Chemistry Department. B.D. Gupta is no more, and Elias is now a professor in IIT Delhi. He shifted from Kanpur to Delhi. Elias did his PhD from this department when he was young. So this book is a very good book because it's written in the style which Indian student can follow, and price is also not very high. It's an Indian edition, easily available. So if you have to follow a book, this is one of the book which you can try. B.D. Gupta and Elias, Basic Organometallic Chemistry. You'll get many things. There could be some errors there, some mistake there in all books. While reading, if you find some error, maybe you have to take care of the error by yourself. Okay. Can you imagine what is octahedral in 3 dimension? Why it is called octahedral? Octa means what? 8. Why it is called octahedral? What is it? 8 faces in the octahedron. I do not have that octahedron, but I have something like. Okay. So this is one octahedral. I put metal at the center, and one I put carbon monoxide, other I did not put anything. You see, the one here is the metal. 1, 2, 3, 4 on the square plane, one above, one below. This is the carbon monoxide. Like that, there will be 6. Chromium hexacarbonyl. If it is chromium, then there are 6 carbon monoxides are required. The formula I have given. What is the atomic number of chromium? 24. So therefore, it's an even number, no issues. CrCO6 is 18 electron compound. Consider this is CrCO6. 1 carbon monoxide I put, 1 and 5 I did not put. So this is called a octahedral. Okay. If you want, you can just have a look, pass it on, quickly, pass it on. So that's a octahedral compound. Okay. So look at here, listen to me. 18 electron rule. There is something else called 16 electron rule. Heard about that? 16 electron rule. Anybody? No? Okay. So there are some compound which give 16 electron in the total count, and the kind. Do you know that NiCl4 2- is tetrahedral? NiCN4 2- is what? Square planar. Do you know that? In crystal field, cyanide is a very strong ligand, splitting is very big. Chloride is a weak ligand, splitting is small. NiCl4 is tetrahedral, NiCN4 2- is square planar. This should be a basic thing. Do you know that? Or you do not know? Who do not know? If you don't know, better you check from coordination chemistry. So the compound which are square planar and there are 4 ligands, those kind of compounds obey 16 electron rule in organometallic chemistry. Do you know any example of a square planar organometallic compound? So far we are discussing tetrahedral, octahedral, those kind of thing. Square planar compound. Are you aware of this compound? Platinum, Pt, Cl3 times C2H4. This looks familiar, this is salt, right? This is salt. Is it new compound for you? How many of you have heard about this thing at least, or able to recognize? So some people are able to recognize. That means if some of you know, other people are also expected that you should know it. This is a square planar compound. It's like platinum. There are 4 binding sites, square planar. 3 are chlorine and 1 is C2H4, and overall there is 1 minus charge. Platinum, if you do not know atomic number, it's okay, I'll help you. Platinum is below nickel in the periodic table. Nickel, below that palladium, below that platinum. So the counting of nickel and counting of platinum are similar. Nickel, what is the atomic number? How many electrons are there? 28. And so total 10 electrons, right? In nickel carbonyl, we get 4 carbon monoxide, which is 8 electron, 10 plus 8, 18. So platinum here, also let's take 10 electrons. Platinum is 10. Chlorine should be how many? Chlorine atom. In a chlorine molecule, 1 chlorine, 7 electron, another chlorine, 7 electron in the bond formation. 1 chlorine gives how many to the other? In a chlorine molecule, 1 chlorine atom is 7, another 7. This become 8. How it become 8? Because this one gives. And this also become 8 because this one gives. So chlorine is capable of giving 1 electron. Platinum 10. 3 chlorine how many? 3. Ethylene. Do you have any idea about how ethylene binds to metal? Probably not. It's a 2 electron donor. The pi bond is a donor. In organometallic chemistry, the carbon-carbon double bond is also a ligand which can provide 2 electrons. So let's calculate 2 electron for that, from ethylene. 10 from platinum, 3 from 3 chlorine atom, 2 from ethylene. And one more is there, where negative charge is there outside, so that is 1 electron. So this become 16. Okay. So the compound which are square planar in nature, they obey 16 electron rule. This is called 16 electron rule. I am not able to go to the detail of all this thing now, but like 18 electron rule, 16 electron rule is also another thing, in which case square planar compounds are taken. Okay. So I will be utilizing this concept for catalysis part. So the class is from 11 to 11:50, then 12 to 2 hours, right? No. So we are in between. Now you have got some idea about how to count electron in metal complexes which are organometallic. There are many kind of ligands which you are not aware of, not exposed to. So I do not expect you to know all those things, but what are the things that you must know? Those I will be telling now for the next class. So now you understand that carbon monoxide is a 2 electron donor, chlorine is a 1 electron donor, methyl is 1 electron donor, and ethylene is 2 electron donor. Okay, so MnCO5 is 17 electron compound. It requires 1 electron, so methyl group can help. If methyl group can help, any alkyl group can help. Ethyl, propyl, butyl, whatever. Let's say I put here methyl, then it become 18 electron. Instead of methyl, if I put ethyl, it's also 18 electron, because this part is not doing anything, right? But instead of ethyl, if I put ethylene, then it will become 19. So it's not good, right? Wherever there is a requirement of 2 electron, then ethylene can fit to that requirement, but if there is a requirement 1, it will not fit if it is neutral. No problem, right? That carbon-carbon double bond just hanging there. So it's not a problem. So MnCO5, CH2, CH double bond, CH2, which is called allyl group. CH2 double bond, CH2 is called allyl. Allyl chloride, allyl bromide, right? So in this case, this is 18 electron compound now. Let's say we remove one carbon monoxide from here. Now it is how many electron? 16. Now when we look at here, this is 18 because 10 and 1, 11, 7 from there, right? I have removed one carbon monoxide now. So it has lost 2 electrons. It wants 2 electrons, right? So this carbon-carbon double bond, if it binds, that compensates those 2 electrons. Then it becomes 18, right? So that means this compound CH2, CH double bond CH2 can be 1 electron donor, or if necessary, it can be no, not 2. 1 electron donor is okay. 2 is not okay. 1 plus 2. So in this mode, it's called 1 electron donor, and in this mode, it is called 3 electron donor, because this and this both are involved. Only this one involved, that is not involved, is not possible, because that becomes a free radical, right? So that's a 3 electron donor. This is 1 electron, this is 3 electron, right? And here we already have 17. 17 plus 1 become 18. Here we have 15. 15 plus 3 becomes 18. Do you know ferrocene? What is that? What is the formula? No, all of you are wrong. You think, okay, give the formula, if not the structure. Fe, C5H5 twice Fe, right? This one. Okay, now draw the structure. That is correct. Formula is correct. Draw the structure. Draw the structure. Or draw the structure of only C5H5 to start with. Okay. First draw C5H5, then we'll say. Let me see who is drawing how. No, I said draw only C5H5. C5H5. So all the bond, carbon, hydrogen, carbon, carbon, everything, single bond, double bond, show it properly. Only C5H5. So carbon, so hydrogen, do not show resonating thing. So carbon, carbon, single bond, carbon, carbon, double bond, wherever it is there, carbon, hydrogen bond, in that way. Like ethylene, how I draw here? I wrote C, double bond, single bond, like that, you draw C5H5 structure. Okay, if I'll give you a clue. If I say draw the structure of methyl, will you ask minus? I say methyl, right? The formula is C5H5. So forget ferrocene. C5H5 structure. If I ask you to draw the structure of methyl, can you draw? How? C, H, H, H and a dot. Okay. So likewise, draw the structure of C5H5 with carbon, carbon, single bond, double bond, hydrogen bond, etc. Draw it. Hydrogens. Put hydrogens. Okay, so it will help to some of you. Is it a cyclic compound? It's a cyclic compound. Some of you are drawing linear compound. Make it cyclic. That is one clue. Draw a cyclic compound. C5H5 is a cyclic compound. What is carbon, hydrogen, single bond, double bond, etc.? Can you draw the structure of methyl? You are missing a dot there, you put it. Then why? What is the valency of this carbon? Go and draw there. C5H5, draw the structure there. In the free space, okay, draw wherever. Put carbon, hydrogen, everything. Okay. So, when we have methyl, in methyl there is one electron which binds with manganese, right? Here MnCO5 CH3 gives one electron, and metal gives one electron that overlaps, forming a bond. Okay. Instead of methyl, I put CH2R, ethyl, propyl, etc. That also has one electron. Okay. If I put CH2, CH double bond CH2, it also has one electron. Okay. If only this carbon binds, it's a one electron donor. In addition, if that also binds, then it becomes 3 electron donor. What is this? I put some more, right? I put one more carbon-carbon double bond. If only this one binds, it's a 1 electron donor. If this one and that one binds, it's become 3 electron. If this and this binds, it's a 5 electron donor. Okay. Instead of CH2, what is CH2? This is CH2, right? I remove this hydrogen, make a bond here. Okay. What it is now? C5H5. This carbon has a dot. So only this carbon binds, it's a 1 electron donor. If this one binds and that one binds, 3. If this and this binds, 5 electron donor. So this is called C5H5. So now C5H5 when completely binds, it's a how many electron donor? 5. Completely, everything. Completely means all its electrons are given to the metal. So 5 electron, is that correct? Iron, how many electron? 18 electron rule. 8 electrons. 1 C5H5 completely binds 5. 1. 5. One more, another 5. 10. Right? 18 electron. So in the ferrocene, C5H5, that is the structure which binds by 1 carbon, 1 ethylene kind of thing. Together it is 5 electron donor, and which every carbon has 1 hydrogen. Everywhere there is 1 hydrogen, therefore the double bond is not localized. It could be sometime here, everywhere it will keep on moving. Right? Therefore, we put it like this. And in that case, this electron is there everywhere. Right? C5H5. Like CH3 dot, 1 electron donor. If it is CH3 minus, methyl carbanion, CH3 dot, neutral. If I put one more dot, that is called CH3 minus, right? 2 electron donor. Cl atom, 1 electron donor. Cl minus is 2 electron donor. CH3 is 1 electron donor. CH3 minus is 2 electron donor. So in MnCO5, CH3, if we think this CH3 is CH3 dot, then that's 1 electron donor. If we say that is CH3 minus, is 2 electron donor. But if we say CH3 minus, you must say Mn plus, because the whole thing is neutral. If we put charge within the molecule, then if you put here neutral, neutral and neutral, total is neutral. The molecule is neutral. If I say no, I want to put a negative charge here, then I must put a positive charge somewhere else. Where else? Only metal. If we say it's a manganese, then how many electron it gives? 7. But if I say Mn plus, 6 electron, and 5 carbon monoxide, 6 plus 10, 16, and CH3 minus, 2 electron, it becomes again 18. So whether you say that is CH3 dot or CH3 minus, there is no problem. If you say CH3 minus, you have to put manganese as plus, right? So in the counting doesn't say CH3 is minus or CH3 is neutral. Counting only say how many electron. Okay? So in MnCO5 CH3, whether CH3 is CH3 minus or CH3 is CH3 dot, that's a separate question. But the counting will not change. Likewise, C5H5 is how many electron donor? 5 electron. If I put a minus charge, it becomes 6 electron. So if C5H5 minus, then here I must put 2 plus, because there are 2. Fe2 plus. Then Fe2 plus is how many electron? 6. And C5H5 is now 6 electron donor each. 6 and 6 become 18. So if I say Fe2 plus, then I must put minus charge there. So C5H5 minus is 6 electron donor, C5H5 dot is 5 electron donor. So that how many electron donors, that is up to us how to calculate. We don't care whether it is minus or neutral, but calculation is not changing. Okay. So like I say that here allyl group, if only this carbon donates, is 1 electron donor. If both donates, then it's a 3 electron donor. Likewise, in C5H5, if only this carbon binds to metal, 1, this and this bind 3, this binds 5. We are not putting charge. If we put charge, only this binds 2, 2 plus 2, 2 plus 2 plus 2. If we say negative charge. Okay. So there are two methods of calculation. One is called neutral method, other is called charge method. Both methods will ultimately give same result. Alright. So when only one atom binds, it's called eta 1. You heard about this is called eta 5, Fe. Do you know this? This one. In front of C5H5, we put a symbol, Greek symbol, which is called eta. And we say eta 5. Is it a new thing for you, or is it somewhat known to you? Or at least have you heard about without understanding or with understanding? You heard about it. So why it is called eta 5? Because all 5 are bound. If only one binds, that will be called eta 1. If 3 binds, eta 3. All 5 binds, eta 5. Likewise, this will be called eta 1. And this will be called eta 3. And that symbol is denoted by the term hapticity. The hapticity of this ligand here is 1, eta 1. Hapticity of this ligand here is 3, eta 3. Hapticity of C5H5 here is 5, which is eta 5. So C5H5 can bind in 3 modes, eta 1, eta 3 and eta 5. In ferrocene, it is eta 5. Is that clear? Okay, so now what we have learned is 18 electron rule, 16 electron rule and hapticity, metal-metal bond. Okay. In organic chemistry, you heard about substitution nucleophilic reaction, substitution electrophilic reaction, addition reaction, elimination reaction. These are the kind of organic reaction we heard about it. In organometallic chemistry also, there are different variety of reactions. Okay. And they are somewhat different from the usual organic chemistry. In metal complex, there is always metal ligand bond. If there is a metal and there is a ligand, then that is called a metal ligand bond. Okay. If we put another ligand, let's say L dash. When I say M and L, something else is also here which I have not said. I am just pointing at one of the bonds. There are so many other ligands around that which we do not care now. M-L bond is there. If this bond breaks, and L dash come in that place. Okay. This is called a substitution reaction. Right. It's addition reaction. Right. So these are the typical way in organic chemistry also you will say. But there are some other things which are not as typical of organic chemistry, which is called oxidative addition reaction. Heard about oxidative addition reaction? Now, who said yes? Tell me what is oxidative addition reaction? Who said yes? Or you say, I heard about oxidative addition reaction, but I do not know what it is, also okay. Somebody said that yes. Who said yes? Why are you worried? Okay. Do you know what is oxidative addition reaction? You know. What did you heard about it in organometallic chemistry or some other thing? Okay. Anybody else? Now you can say, yes, I heard, but I don't know. This is it. Okay, oxidative addition. There are two terms, oxidative and addition. What do you mean by oxidative? It's a kind of oxidation, right? Oxidative means something related to oxidation. And addition means something related to addition. Okay. Let's say M, something is around it. M doesn't mean just free metal, something around it. Plus X, Y. Okay. So let's say XY bond breaks. Then X has 1 electron, Y has 1 electron. Okay. And from the metal, remove 2 electrons. Then whatever is the oxidation number of metal, it will increase. Let's say M is M1 plus charge. Remove 2 electrons. It become M3 plus. M is N plus. Remove 2 electrons. It become N. M is charge is N plus. If I remove 1 electron, N plus 1 plus. If I remove 2 electrons, N plus 2 plus. This many plus charge, right? And those 2 electrons give 1 electron here, give 1 electron here. So whatever 2 electrons are removed, they are given there. So now let's say X minus and Y minus. This become minus charge now. They come and bind here. By donating 2 electrons. Then oxidation has happened on this thing, and also addition has also happened on that thing. So this kind of reaction is called oxidative addition reaction. I will give with example what is oxidative addition reaction. So shall we take a break of 5 minutes? Are you saturated? Okay, so we will take a break of 5 minutes. Those who want to take break, want to go outside, want to go toilet, want to go talk something and come back. We'll start in 5 minutes. Those who want to stay here, stay. I am here. If anybody has any doubt for this 5 minutes, I am here. And those who want to go outside can go outside. We can stop for 5 minutes.
SwayamPrabha, Digital India, Educated India.